For over a century, gold mining was a matter of brute force, men panning in cold rivers or chipping away at solid veins of yellow metal in the dark. But the easy gold is gone. Today, the metal is trapped as microscopic specks, locked deep inside extremely stubborn stone. This is refractory ore. It acts like a toxic fault, physically guarding the gold with high levels of sulfur and a massive amount of arsenic, sometimes up to 10% of the rock's weight. Since smashing the rock won't release the gold, the stone has to be ground up and sprayed with chemicals. It is an industrial process that looks exactly like brewing a cup of espresso. Managing this highly toxic, precise brew without destroying the multi-million-dollar machinery requires a near-perfect chemical balancing act. Before the brew begins, the raw material must be prepped. The rock goes through a two-stage roasting process. Intense heat burns off the sulfur and arsenic, turning the hard stone into refined, sandy particles. Next, that sand gets an aggressive wash with sulfuric acid. This pre-wash strips away the leftover impurities that would otherwise contaminate the system. Now we reach the actual extraction, a step called cyanide leaching. A cyanide solution is showered over the sand, acting exactly like hot water hitting coffee grounds. As it flows through, the cyanide physically dissolves the microscopic solid gold. It pulls the metal out of the rock and carries it away in a clear liquid stream. While the chemistry is microscopic, the scale is massive. These industrial plants use enormous tanks to process tons of toxic material every single day. This cyanide brew is excellent at freeing the gold, but running these harsh chemicals at such a high volume introduces a dangerous vulnerability to the machinery itself. Leftover impurities from the acid wash act like hard water inside an espresso machine. Over time, minerals start to collect where they don't belong. Originally, engineers used lime to stabilize the chemical brew. However, the lime introduced massive amounts of excess calcium into the system. That calcium caused extreme crystallization. Crystalline scaling grew along the inside of the pipes, eventually narrowing the flow until the entire plant ground to a halt. To keep the liquid moving, the team swapped out the pipe-clogging lime for a smoother protective base called sodium hydroxide. The new mix prevents the crystals from forming. Clearing the pipes with better chemistry is a start, but the engineers also have to block the raw impurities from sneaking into the tanks in the first place. Impurities enter the system through excess moisture left over in the sand after the acid wash. The wetter the rock, the dirtier the final brew. To stop this, the plant installed automatic ceramic filters. These machines forcefully squeeze the wet slurry until it reaches a strict 45% concentration before the cyanide ever touches it. They even changed how they clean the filters. Instead of using water, which would add moisture back in, they switched to pressurized gas to blow the filters clean. By regularly soaking the ceramic plates in a lye solution, they keep the suction high and the sand dry. This maintenance step alone saves the plant over $75,000 in replacement costs. Controlling the physical moisture and the chemistry before the brew begins is the only way to ensure a healthy, pure extraction. These combined fixes create a perfect environment, a clear liquid holding over 1,000 milligrams of dissolved gold per liter, stabilized at a pH of 10. At this stage, the gold is still a highly toxic liquid. To be useful for currency or jewelry, it has to be turned back into a solid. To do that, engineers use zinc powder replacement. They sprinkle a fine gray zinc powder directly into the tank of clear liquid. The zinc chemically swaps places with the gold. The liquid absorbs the zinc, which forces the gold to precipitate and drop to the bottom of the tank as solid particles. Those solid particles are collected, melted down, and cast into bars. It is the final, tangible result of a very long and complex chemical journey. Modern mining has moved past the pickaxe. Today, it is a feat of microscopic chemistry and relentless industrial problem-solving.